So we learned about points, we learned about lines, line segments, rays, and then we learned about the different types of angles. But what happens if we have more than two lines put together? Well, eventually that will make a shape. And the smallest shape, or the shape that uses the least amount of angles, or perfect lines, would be a triangle. And tri means three. So there are three lines, three angles, 3 points. And when we look into triangles, we can classify them in different ways. The first way is by how many sides are in a triangle, or not how many sides, but what the side lengths are. So if you look at this triangle right here, although they're not labeled, all three of these sides are the same length. So I could say that this side is 2 inches, this side is also 2 inches, and this side is 2 inches. They're all the same, which means that they are equilateral, which means that this triangle is equilateral. Okay? An isosceles triangle. So this one looks really similar, but what if they tell us that this side is 2 inches, this side is 2 inches, and this side is 3 inches? Well, this is no longer equilateral, right? Because all three sides aren't the same, only two. So that would make this triangle an isosceles triangle. All right. Now, what about if we have no sides the same? We have all kinds of funky triangles. What if this one is 5, this one is 2, and this one's 1 inch? Okay, well that one's going to be, it's not either of these. So that would make it scalene, which means that none of the sides are the same. So review: equilateral, all three sides are the same. They're all equal. Isosceles, only the two are equal. One of them is not. And scalene means none of them are equal. But that's not the only way to classify a triangle. We can also classify them by their angle. Now, the easiest triangle is one that has a right angle. Okay, that means that it has one right angle in it. And so this would be a right triangle. Now, you can classify this by its sides too by saying this is also scalene because this side, and this side are all different lengths. But when we're focusing on the angles, that means that it has a right angle, so it is a right triangle. Now, what if we have a triangle that has an obtuse angle? It doesn't have any right angles. Well, that would be an obtuse triangle. Okay, so it must have either an obtuse angle or a right angle to be an obtuse triangle or a right triangle. If it doesn't have either of those, then it is an acute triangle, which means that all three angles are the same, and they're not the same, but they're all under 90 degrees. So, for example, this one would be an acute triangle because all are under 90 degrees. This one would also be acute, but this one, it's not right. It is obtuse because it has that big old larger than 90 degree angle. Okay? So that is how you classify triangles. Now let's get into the nitty gritty, the math of it. Okay? This is an obtuse triangle. It is also scalene because all the sides are different. But we're going to focus on the inside. We want to focus on the angles. And this side is 100 degrees, which means it is larger than 90, which means that it is obtuse. This side is 55, which means it's acute. So what is B? We don't know. Well, a triangle, if you add all three angles together, you will get 180 degrees. So to find out what angle B is, we need to add these two together. So 100 plus 55 would equal 155. Okay, we know that this whole entire triangle needs to be 180 degrees. So all I need to do is subtract 180 minus 155. Okay, so let's do that. 0 minus 5, can't do it, so we're going to have to take one from the 8, and it'll turn into a 7. Okay, once that 8 turns into a 7, I need to take a 10 and make that 0 turn into 10. 10 minus 5 is 5. 7 minus 5 is 2. 1 minus 1 is 0. So they're saying that angle B, or if I wanted to write this as angle B, equals 25. Now 25 what? There's got to be some kind of label. Well, if you look at the other two, they have this little circle up there, and that means degrees. Okay, so angle B is 25 degrees. Now you can check your work and say, okay, well, let me make sure though. Is this for sure an acute angle? Okay, well, here's a 90-degree angle, so it's definitely less. So yes, 25 degrees works for this. You can also tell by the size, this one's pretty small, where the 55-degree angle opens up a little bit wider. Let's try this again. All right, we have 56 on this one, 71 on this one, but what on K? So 180, I'm going to write that right away. All triangles are 180 degrees. Now let's add these together. 6 plus 1 is 7. Just remember you're adding those two together. 5 plus 7 is 12. So I should have 127. I subtract 180 minus 127. Again, I'm going to have to get rid of that 0, make it a 10, make that 8 turn into a 7, and then subtract. 10 minus 7 would be 3. 7 minus 2, I would get 5. So that is telling me that angle K is 53 what? 53 degrees. All right, and the way to check your work is to add them all together. So if I add 71 plus 56, I got 127, and then 127 plus 53. Well, 7 plus 3 is 10. 5 plus 2 is 7. Plus 1 is 8. 1 plus nothing is 1. So this does make a perfect 180 degrees. Then we'll do one more practice. So 41 plus 58. Add those two together. I'm going to get 8 plus 1 is 9. 4 plus 5 is also 9. So I have 180 minus 99. All right, this one's going to be a little more regrouping than the last ones. So this turns into a 10, this turns into a 7. 10 minus 9 is 1. All right, I'm going to take that 1, put it up there. So 17 minus 9 is, oh gosh, 17 minus 9 is 8. So x would equal 81. Now, on these other two, they don't have anything there. That's totally fine. They just put a x there, meaning that they don't know what it is right now. But we figured out that that equals 81. You'll learn in 6th grade that this is called a variable. So we'll learn about that later. But this angle is actually 81 degrees. So we kind of figured out the last two are actually acute triangles because none of them have 90 degrees or higher. All right. And you're going to be doing IXL this week, or today for this. So just practice on IXL. And yeah, there you go.